So anyone who knows me in real life knows that I've spent a little bit of time recently speedrunning GCSE maths papers. It's a very exciting time now for the speedrunning of GCSE maths papers community because a new strat has just been found for a particular type of question, which is going to shorten the record times, I think, is my prediction. And it's questions like these. So if you'd like to, you can, if you're a GCSE mathematician, you can pause the video and do this question as fast as you can. Whatever time you can do it in, it's probably going to be longer than the 3 seconds that this question takes me. And this is why, building up these strats, finding these things is going to be really important to the speedrunning of GCSE maths community. Yeah, to do this then, so normally what you do is you find this radius, you find the gradient of it, then you do the negative reciprocal to find the gradient of the tangent, and then you have the gradient of the tangent, you have a point, so you put that point into y equals mx plus c with the gradient, and then you sort it out and you get some answer. None of that is necessary here. What I need is I just need to jot down the equation of the circle. Now, this is the 0.34, so that's 4 squared plus 3 squared is 5 squared. So the equation of the circle is x squared plus y squared equals 25, so I can do that very quickly. And then to work out the equation of this tangent, all I need to do is, and this is going to look a bit weird, but I'm going to write it like this first. And of course, if I was actually speeding running this, I wouldn't write this down. But just to be clear, x squared is x times x, y squared is y times y. This is the coordinate xy, that's how coordinates work, xy. I'm going to put one of the x's in, but not both, and one of the y's in. So I'm going to make one of the x's 4, one of the y's 3, and that's the equation of the tangent to the circle. Of course, if you make it both x's 4, then you just end up with 16 plus 9 is 25, and great. But if you just replace one of the x's and one of the y's, then you end up with an equation line, and this is the correct answer. Of course, if I was speedrunning this, I probably wouldn't even jot down the equation of the circle. I would just have that in my head, and then just put a 4, a 3 in front of these, lower the powers down, and then keep the 25. I can show you it this way here if you want. That's the y coordinate, probably wouldn't bother to write it down. Just literally replace one of the x's with a 3 over 2 and one of the y's with a root 7 over 2, and the answer will be 3 over 2x plus root 7 over 2y equals 4. That is the equation of the tangent. There is absolutely nothing else that's necessary to be done. In case you're an A-level mathematician, you can actually do this for A-level circles as well. In A-level maths, the only thing that's different is that the circle isn't centered at the origin. So it could be centered anywhere, like -2, 3. Of course, if it goes through this point, then the distance between the center and this point is the radius, so I can just do Pythagoras. Distance between those two is 3, distance between those two is 5, to find the radius, and then I can say the equation of the circle, you flip these two signs and put them in brackets with the x's and y's, a bit like this. So that's the equation of the circle. I guess show this for the hell of it, yeah, sure, whatever. Now, this is the juicy bit, right? Find the equation of the tangent. This is worth 5 marks. Just write down your equation of the circle, but just repeat the thing rather than using a squares notation, just like before. And then again, replace one of the x's with a 3, not both, and one of the y's with a 6. Simplify it up, expand out. You could do it in less lines than that. I was just trying to be very clear. That is the equation of the tangent. Again, there is very little work necessary. Of course, what's really exciting, the most exciting thing about that is obviously the fact that the times are going to start falling down now. Every time we see that question as a community, we can just do it in 2 seconds. But possibly what's even more exciting is let's actually prove that this does actually work. I'm not just making this up. It is actually a thing that you can do. Like, why is it a thing that you can do? So, and I would encourage you actually, before I do this, to try and prove this yourself. Like, just prove that, for example, this does actually work. Like, that you can just write it like that. I would highly suggest that you pause the video again and try that now. Otherwise, let's do the proof then. So you have a circle, x squared plus y squared equals r squared, where r is the radius, of course. We're just doing centered at the origin here. Of course, after I've done this, you can then extend the proof to circles centered not at the origin if you want to, but let's just prove this really quickly. Just say you've got some point on it, which is AB, and we're looking for the equation of this line, which is tangent to the circle at this point. Now we can say that, of course, the theory is that if you just put A in for one of these x's and B for one of the y's, that the theory is that this blue equation is the equation of this tangent. That's what we're hoping. So let's try and prove it then. And now, okay, for this to be the tangent of the circle, we need 3 things. We need this blue thing to be a line. We need it to pass through AB. And we also, because of course there are lots of lines that don't pass through AB, we need it to pass through AB. And we also need it to have exactly the right gradient. because of course there are lines that go through AB that aren't tangents because they have the wrong gradient, like this or this. We need to have the perfect gradient here. So we need these three things. If we could show that this thing here is all of these three things, then it's definitely this line here, and therefore this entire method works well. So okay, is this a line? Well, yeah, it is. And if you want to, you can rearrange it to prove it and get it in the form y equals mx plus c if you want to. Otherwise, you could have just looked at this and gone, well, lines are just when you have a single x power and a single y power, like that. That's all it is. So yeah, this is definitely a line. So the blue thing is good in that respect. Does it go through AB? Of course, we need it to go through AB if it's going to be the right line. Okay, well, let's substitute AB into here for xy. I said again because we've kind of already done it, haven't we, for one of them, but we'll do it again for the other two now, and we get this. But of course, this is true because r is the radius of the circle. A is defined to be the distance across to this point, B is the distance up. And we can see here we've now got a Pythagorean triangle, a squared plus b squared equals r squared. So this is a true statement. And so because this is a true statement, this line does pass through AB because you end up with a true statement when you put it into the line. So this is true as well. So we've proved two of the three things. Lastly, does it have the right gradient? Well, to prove that again, I'm just going to rearrange it again. So we've already done that, but let's rearrange it. The gradient of this line is minus a over b. And now, to be a tangent, you need to meet the radius of a circle at 90 degrees. But the gradient of the radius, which would mean the gradient of the radius needs to be the negative reciprocal, but of course the gradient of the radius is just b of a, which is indeed the negative reciprocal of the gradient of the line. And so these two things, this radius and this tangent, do meet at 90 because we've got this relationship here, and therefore it is perpendicular to the radius, it is a tangent, and we meet all the three criteria, so this is definitely the correct answer to this question. So yeah, just a really nice little trick that answers this question just super quickly. I wouldn't recommend going into a GCSE exam with this being your only tactic. This is just for the speedrunning community, I think, because of course the moment they change the question to be ask you to do anything else slightly more complicated, this method kind of falls apart if you ask to do it backwards, for instance, or anything like that. So yeah, you do need to understand the usual principles for this kind of question, but if you are interested in speedrunning in GCSE papers, this is definitely a little trick to have definitely tucked in the back of your mind because it will help you out a lot.